Welcome to lesson 2.8. In this lesson, we're going to use our knowledge of graphs to be able to infer things. So we're going to look at line graphs, pie graphs, bar graphs, and be able to figure out what they're telling us. So the first one we're going to look at are two line graphs. And they're both giving you the same information. So one kind of looks like a straight line, whereas the other one looks pretty curved with a point. So you want to be able to tell what's the difference between the two. And if I look at the years are the same. If I look at the y-axis, though, that's where the difference lies. So if we're looking at number 2, what is the average household income in 1999? For both of them, we can see that it's about 50 to 400 maybe. So based on the two graphs, is it fair to say that it was significantly lower? And then you want to explain. The key word is significantly. So kind of analyze that, figure out if it's significant. Bar graphs. So the questions about Jeff's housing should look familiar. And we're talking about his income increasing maybe over the last 2 decades. So you want to be able to calculate his income over those decades. And we looked at the formulas in a previous video. So check the class notebook for more tips if you don't recall that. So let's move to GDP, gross domestic product. Now, the national debt is how much a country owes. Just like we graphed income, we can graph debt. So here we're looking at 2 different graphs. One is in trillions of dollars and one is a percentage of the GDP. So you can see the y-axes are different, but the x-axes are the same. Remember, horizontal is our x and then the vertical is our y. So you want to be able to tell the difference between the two. So what was the national debt in dollars in 2010? You would look at the first graph. And then for the GDP, you would look at the second graph. So we've looked at line graphs, bar graphs, now pie graphs. So pie graphs are those circle ones that usually have percents in them. So this is kind of, you're predicting, decide if the statement's true. And it says 2010, here's our populations and then the US population. Does this predict that the number of non-Hispanics is expected to decline? And then you're saying true, false, or not enough. Then you're going to analyze those. So let's look at number 8 together. The population in 2010 was around 310 million, and then in 2050 it's expected to be 439 million. So we can see it's going up, and then we need to do some more analytics. So if we have the total population, we can find the non-Hispanic population. So in 2010, the non-Hispanic population was 84%. So we're going to find 84% of 310 million. And then for 2050, the non-Hispanic is 70%. So we're going to take 70% of this time 439 million. So let's calculate that on a calculator. So when I calculate those two, I get 260 million non-Hispanics in 2010, and then a projection of 307 million non-Hispanics in 2050. So we can see now that the statement is false because the number, right, we're looking at number, actually increases. The pie charts we're given don't show number, they show percent. So that's why it's important to realize what you're analyzing, percents or numbers.